Hi everyone, this is Mr. Siu from Math Accelerator, and in this P4 revision, we're going to focus on whole numbers, and the problem sum strategies that we're going to go through today will be constant difference, constant total, and stacking model. And in this question, we're going to talk about constant difference. I will read the question first and I'll explain to you how we solve this question using this constant difference heuristic. Patrick had $72 and his sister has $8 at first. After they receive an equal amount of allowance, Patrick has twice as much money as his sister. How much allowance did each of them receive? So number one, let's underline the keywords. Patrick has 72, his sister has $8. So this we know the beginning amount for these two of them. After they receive an equal amount of allowance, another keyword here is the equal amount of allowance. Patrick has twice as much money as the sister. How much allowance did each of them receive? So after reading the question, let's organize this information that we highlighted in the form of a model. So we know that Patrick has 72 and the sister has $8. So we write here $72 and over here 8. They each receive an equal amount of allowance. So please take note that this allowance we have to put at the left hand side like this. So we write a letter A to represent the allowance, and here is Patrick's model and this is the sister's model. Next, we were told after they were each given the equal amount of allowance, Patrick now is twice as much money as the sister. So we know that whatever he has will be 2 units as compared to the sister who has 1 unit. Right, so why is this question called constant difference? We notice that the difference over here which is initially the difference of 72 and $8 is the same difference as in the end, right? So the difference at the beginning and at the end, they remain the same. Only thing difference is now, the difference is 1 unit, right? Because 2 unit minus 1, the difference between what they have in the end is 1 unit. And this 1 unit is also equals to the difference of 72 and 8. So we know that 72 minus 8 will give us 64. So therefore we know that 1 unit is equals to 64. Next, we will use the sister's model to calculate the value of the allowance given to each of them. We know that 1 unit is 64. Therefore, the allowance plus $8 will give you 64. So to find the allowance, we simply take 64 minus 8 and we will arrive at the answer of 56. And that's how we arrive at the answer. So this is constant difference. Okay, how do we identify constant difference, right? So you notice that the beginning difference and the difference at the end, they are the same. So is one of the recommended way to solve this question is to visualize this problem sum in the form of a model. Then you identify the difference, which in our case is $64. So after you find the $64 equals to 1 unit, you can use the sister's model and use this to solve for the allowance given to each of them. Okay, let's move on to the next question. In this question, the heuristic will be constant total, and sometimes we call it internal transfer. Internal transfer happens when one person has a certain amount, another person has another amount at the beginning, and during the change, person A will transfer a certain amount to person B. You notice that the total at the beginning and after the transfer will be the same because the transfer is only internal between the two persons. Okay, let me read the question and explain further to you. In this question, Lydia has twice as much money as Kenneth at first. Kenneth then gave Lydia $24. In the end, Lydia had 4 times as much money as Kenneth. How much money did Kenneth have at first? So let's underline some of the keywords in the question, and they will include, okay, we have a comparison between Lydia and Kenneth at first. Then Kenneth gave Lydia $24. In the end, Lydia has 4 times as much money as Kenneth. So how much money did Kenneth have at first? So after reading the question and underlining keywords, we'll organize the information in the form of a model, and we will draw Lydia's model first. Lydia is twice of Kenneth. So this is Lydia, this is Kenneth. Now, here is the internal transfer, right? Let's indicate here internal transfer. Okay, the transfer is between Kenneth to Lydia. After Kenneth transferred $24 to Lydia, Lydia now becomes 4 times of Kenneth. So what we do is we're going to draw another model. So before that, we indicate that this is the before model. That means before the transfer. And we're going to draw a model for after. Right after. So after, we know that Lydia becomes 4 units. So we draw slightly longer. And this will be Kenneth. Kenneth is down to 1 unit. Lydia, Kenneth is 1 unit, and Lydia will be 3 units. Now, since it's internal transfer, we know that the total will be constant. That means they remain the same. That means the total over here and the total over here will be equal. So we have to find a number of units that at first can be divided by 3 and in the end can be divided by 1, 2, 3, 4, 5, right? Because these two sets of model will hold the same number of units. So we're going to find what is the common multiple of 3 and 5, right? CM stands for common multiple. So you notice that the common multiple of 3 and 5 will be 15. Therefore, we will have 15 units at first and 15 units in the end, right? 15 divided by 3, it will be 5. So therefore, we know that there will be 5 units over here for the before model. And below, it will be 15 divided by 5, you get 3. So we know that every box will be 3 units. Okay, our focus now will be on Kenneth, right? Kenneth used to have 5 units, and after transferring $24, he's left with 3 units, right? So therefore, we need to find out what is the amount that was transferred to Lydia. So let's focus on Kenneth. So before he has 5 units, now he's left with 3 units. So we know that 2 units was transferred away from Kenneth and to Lydia. So these 2 units is exactly equals to the $24 as mentioned over here, right? So 2 units is $24. Therefore, 1 unit must be equals to 24 divided by 2. That will give us $12, right? So now we know that 1 unit, the value is $12. We're going to find how much money did Kenneth have at first. Kenneth has 5 units at first, so we're going to find the value of 5 units. So Kenneth at first. So 5 units, therefore $12 times 5, and we will get $60. So that's the answer for this question. So always remember, if one person transfer to the other, an internal transfer will occur, right? When this happen, when an internal transfer happen, always remember that the total will remain constant. Therefore, as we illustrated, if we have 15 units before, we should have 15 units in the end. And from here, we should be able to track the changes for Kenneth. Kenneth used to have 5 units, now he's down to 3 units. So the difference of 2 units is equals to 24, 1 unit will be 12. And to find Kenneth, which is 5 units, we just simply take 12 times 5 and we arrive at $60. Okay, let's move on to the next question. In this question, we're going to talk about this strategy called stacking model. Now, in stacking model, the models are drawn vertically instead of horizontally as most of the time when we draw part whole model, right? So let me read the question to you and explain how we use the stacking model strategy to solve this question. Peter bought 3 shirts and 2 bags for $299. Each bag cost $17 more than a shirt. How much did the bag cost? So in this question, the keyword will be we have this group of items that cost $299. Each bag costs $17 more than the shirt. So from this statement here, we will know that the shirt is the cheaper item, right? So the shirt will be 1 unit. So we write over here, 1 shirt is equals to 1 unit. And the bag is $17 more, therefore each bag will be 1 unit plus $17. So this is the basic information that we derive from this statement. Okay, based on the earlier statement, we know that 3 shirts and 2 bags will cost Peter $299. So we will draw 3 shirts. Okay, this is 1, this is 2, and this is 3. Right, so here we have 3 shirts and we have 2 bags. Remember, each bag costs more than the shirt. So this is how we draw this. 3 shirts and 2 bags. So each bag is $17 more. And their total is $299. So from here, we can form the equation. We will be able to see that on the left side, we have 1, 2, 3, 4, 5 units. So right here, 5 units plus 2 sets of 17. So it should be 17 plus 17, and this will give us a total of 299. 17 plus 17 will give us 34. So 5 units plus 34 will give you 299. Next, we will find the value of 5 units by taking 299 minus 34. Let's check. Okay, so this will give us a value of 265. Next, we will find the value of 1 unit. So if 5 units is equals to 265, we will take 265, then we divide by 5, and we will arrive at 51. So now we know that 1 unit is 51. We're going to find the cost of the bag. So 1 bag is 1 unit plus $17. So we can use back this equation. So we have 51 plus 17. So 51 plus 17, 1 plus 7 is 8, 5 plus 1 is 6. We will know that the bag will cost Peter $68. So our answer for this question will be 68. Right, so this is called stacking model. Stacking model is useful when we're comparing two items with different values, right? And we have this information that one of the item, which is the bag, costs $17 more than a shirt, right? So this is the basic comparison, and we know this group of items that consists of three shirts and two bags will cost $299. So this is how we use this information to solve the question, right? So we organize this information in the form of a vertical model, which we call the stacking model, and after we drawn this, we're able to form the equation. Okay, the equation will be 5 units plus 34 equals to 299. And from there, we solve for 1 unit. Right, 5 unit is 299 minus 34, which will give us 265. From there, we divide this number by 5, and we know that 1 unit will cost us $51. Then we go back to find the cost of the bag. The bag is 1 unit plus 17. So we work out that 51 plus 17 will give us $68. And that's how we arrive at this answer. Okay, hope you find these three strategies interesting. Do revise for it, and I'll see you in the next video.